Mr. P's Science and Math Podcasts. For more science and math concepts, search me out on iTunes by typing Papapodcasts. You can contact me at mrplieberman@gmail.com. Thank you for watching. So, let's graph our last quadratic expression. And we know that it's going to be quadratic. But now let's see how it changes. Okay, so take a moment here, complete the following table of values. So pause the video now. We're back. So I'm assuming you've already completed the following, and whenever x is equal to the following, here are the values that we get. Notice how you can almost predict where the vertex is. Look at where the vertex is. Right here. Because from this vertex, the next numbers here for y go 3, 12, 27. Here, the values go 3, 12, 27. The same numbers. But from where? They start from wherever we identify to being the vertex. Okay. So let's look at the difference now. From 27, let's use a different color here. 27 to 12, 15. From 12 to 3, we have 9. From 3 to 0 is 3. From 0 to 3 is negative 3. From 3 to 12 is negative 9. And from 12 to 27, it's negative 15. So look at this spot here, where we get the difference being the same. Here we have numbers on the positive side of x. Here we have numbers on the negative side, or should I say the other, sorry, the opposite. Okay, and what we have here, from here, where was this point here? The leveling off. It happened right here. And what do we call that leveling off there? That's where that vertex is. That is also going to be the location in which we're going to put our mirror to reflect both sides of the equation. And let's look at the second difference. And the difference is as follows. And because the second difference is the same, we know that the following is quadratic. So let's graph it. So here we have, notice the three graphs as our value for A, and I don't know if you can see it here, let me retouch it in case you can't see it. Here is our parabola. Might have been maybe awkward, but let me just draw that in there, but that's where it is, and I'm going to erase that now. Okay, so it looks a lot neater. Notice how the value of A, as this value of A, okay, notice here the value of A here was 1. The value here is 2. The value here is 3. So as the value of A increases or becomes greater than 1, notice how the parabola starts to go inward. Okay, but now notice where the first point was. The first point, from the vertex, the first point from the vertex is there. On the inner parabola, the first point after the vertex is there. For the inner parabola, the first point was there. So notice here, now in terms of the parabola, what we have here is as the value of A, got bigger than 1, the parabola started narrowing. Okay, it started narrowing, so it would narrow, but it would stretch vertically. Okay, notice where the first point is. Here's the first point for the original equation, and we're going to make reference to y is equal to x squared as being the original equation. Okay, because what we're going to see is that all parabolas to some extent is congruent to this, y is equal to x squared, but with some kind of various transformation. Okay? And so notice here now, depending on what the a value was, look at where the stretch was. So the stretch here increased from 1 to 2 for this point. It increased to 3 for this point. So in fact, the movement of the points reflected whatever the value of a was. So if the value of a was 1, it remained whatever it was. But if the value of a was 2, the points all multiplied by 2. If the value of a changed to 3, everything multiplied by 3. And we're going to see that when we compare and contrast pretty much the table of values of all the ones that we've already graphed. Okay, so notice the vertex for all these parabolas, we're all at 0, 0. The axis of symmetry is the location on the x-axis where we can place a mirror and get the same reflection for the graph. So notice here we have the mirror here in the middle. Okay, this is the mirror. And notice we get the same reflection on both sides. Okay. So let's compare and contrast. So let's move this here because we can't see what that equation is. So here we have the equation that we worked at. Y is equal to x squared, y is equal to 2x squared, y is equal to, and here this one is 3x squared. Okay? And let me rewrite this one up here. Okay, if you can't see that bottom one from home. Now, notice what the difference is. Let's identify where the vertex was. And the vertex is the location in which this second difference moves pretty much in the same order. And it all happens, where does this all happen? It all happens right here at 0, 0. That 0, 0 is what we call the vertex. And the vertex, okay, this vertex is one of the most important points when graphing parabolas. One of the tips for using the short way, or the shortcut to graphing parabolas, is to identify the vertex. Secondly is to identify the vertex is first. Second, pretty much find your a value. And the a value here is 1 for this equation. For here the a value is 2. For here the a value is 3. Now notice how we said all parabolas are going to be what we call congruent to this one. Let me erase some of this so it doesn't get too messy here. So here is this one. And this is the main parabola that we're going to be focusing on to help us answer every single parabola. From here, if we look at from this original parabola, and we look at, remember we said now we were going to revisit these numbers, 1, 3, 5. Look at how we derive from 1, 3, 5